This lesson is a continuation of the previous lesson. So recall in the previous lesson we were looking at writing equivalent rational expressions. But in each case you were asked to rewrite the rational expression with a given denominator. So for example, in number 3, your denominator was 15y and you wanted to write an equivalent rational expression that had 30y to the fourth as your denominator. And so we had that discussion. Well, how do we do this? So in this lesson, though, it's a continuation of this, but more in tune of what it would look like in the next lesson when you add and subtract rational expressions. So let's focus on this particular lesson, knowing how to deal with the previous one. So the directions for this will probably say something like this. So the directions will say, find the least common denominator for the rational expression. So notice there are going to be 2 rational expressions. And then write the equivalent rational expression with the LCD. So for example, number 1. So you have these 2 rational expressions. Now notice the difference between number 1 and the previous one. So it's almost the same idea except you're looking at it in a different perspective. So knowing this, though, will help you with this as well. So number 1, you have these 2 rational expressions, and you want to find the least common denominator of those 2. So first of all, we got to find the least common denominator. So the least common denominator, remember these are monomial factors, so that's the easy kind. So the least common denominator must include every factor you see. So in order for this denominator and this denominator to go into the least common denominator, these factors must be present. And so here, so I need an x and then I need a y. And then the question is, remember in lessons you've had, the question is how many factors of x do you need and how many factors of y do you need? Well, there's only one factor of x here, there's 0 here, so all I need is 1. There's 1 factor y here, 0 here, so all I need is 1. So there's your LCD. So that's the LCD. Then the next thing, so once you find the LCD, then the next thing is to write the equivalent rational expressions with that LCD. So basically, here's the next thing. So the question is 6 divided by x equals what rational expression with this denominator? Okay, and then 5 divided by y is equivalent to what rational expression with that denominator? This is where this comes in. So see, that's the idea here. So each of these is going to be this idea. Okay? So look at what you have. I have a factor of x. This is what I want to end up with. All right, so I want to end up with x times y. So what's missing here? The y. So what some students will do is they'll just say, they'll say, all right, so I'm going to multiply this by y. What I do to the denominator, I have to do to the numerator, right? And so then I get 6y. So that will be your answer. So 6 divided by x is equivalent to 6y. But remember we did it in the last lesson, and to understand why this is true. Because in the last lesson, remember if I take 6 divided by x, I've got to multiply this by some expression that's equal to 1 to get a denominator that's xy. And so if I multiply x by y, I will get xy, but what I do to the denominator, I do to the numerator. And so 6 times y is 6y. And so that's where this comes. But most students will end up using this idea rather than writing this whole thing out. But keep in mind that y divided by y is this one that you learned in the last lesson. So that was this last lesson that you looked at, where we talked about multiplying by 1. Multiplying by 1. Okay? And then we can do the same thing with this one. So what do I need to multiply y by to get xy? Well, y times x is xy, but what I do to the denominator, I have to do to the numerator, right? Because x divided by x is that 1 that we were referring to. So my numerator then is 5x. And so there's your answer to that one. So write equivalent rational expressions with the LCD? You did. So note, 6 divided by x is equivalent, 6 divided by x is equivalent to 6y divided by xy. Okay? Because when you reduce, remember when you simplify from a previous lesson, the y's divide out, you get this back. And then also 5 divided by y is equivalent to 5x divided by xy. And again, if you simplify, if you reduce these x's, you get 5 over y, which is this. All right, so that will be your answer on that part, and that's the answer on the other part. So this is the LCD, and these are your equivalent rational expressions. Okay, number 2. Number 2, let's suppose we had this for number 2. We have um, 8m divided by 8 cubed b to the 7. So there's one rational expression. The other rational expression is 4t divided by a to the 5th b to the 3rd power. So I have these two rational expressions. I want to find the least common denominator of those two. So the LCD. So remember, your coefficients are 1. So I don't. My LCD is going to include the coefficient of 1, but we're not going to write it. I see factors of A, so I need some factors of A. And if I look at all these, I also see factors of B. Okay. The question is, how many factors of A do I need? And you want to use the smallest amount here in the LCD. So you have 3 factors of A here, 5 factors of A here. Remember, when finding the least common denominator, whatever exponent goes here, this has to go into it, and this has to go into it. So I need to use the largest exponent. Okay, so when finding the least common denominator, do not get this confused with the greatest common factor. That's different. With the least common denominator, the least common multiple, remember this is least common multiple idea. With the least common multiple, you're going to use the largest exponent because it's the only way, that's the only way that a to the 3rd, a to the 5th will go into the LCD is if you use the largest number of factors. So a occurs 3 times here, a occurs 5 times here. I got to use the largest number, 5. Same thing with B. So B occurs 7 times here, 3 times here is a factor, so I got to use 7. So there's your LCD. So the first thing you had to do. Second thing you had to do is write equivalent fractions. So the question is 8m divided by a to the 3rd, b to the 7th equals what fraction equivalent to this LCD? That's the question, okay? All right, and so then look at what you have. I have a to the 3rd times a squared will give me a to the 5th, right? So I got to multiply. I have to multiply a to the 3rd by a squared to get a to the 5th. B to the 7th times b to the 7th I already have, right? I didn't mean to say times, but b to the 7 times 1 is b to the 7th. So all I need to do then is just multiply. This rational expression by a squared divided by a squared. And so remember from the previous lesson, that's still a 1. So am divided by a cubed b to the 7 times 1 is still this. So then the answer is going to be am times a squared is 8a squared m. I just put it in alphabetical order. It didn't matter. All right, and so note, you found your answer will be 8m divided by a cubed b to the 7 is equivalent, and we're using the word equivalent, meaning they're equal to each other. So if you were to reduce this, you would get this back, is equivalent to a squared m divided by a to the 5th, b to the 7th. In the second one, you have 4t divided by a to the 5th, b to the 3rd power. And you want to find out, so you got to multiply this by some expression, and you want to get an expression that has this denominator. So a to the 5th, b to the 7th. So then you're going to multiply. So a to the 5th times 1 is a to the 5th. So I don't need any a's here, any factors of a. I have 3 factors of b. I want 7 of them, so I need b to the 4th, because b to the 3rd times b to the 4th is b to the 7th. But what I do to the denominator, I do to the numerator. So notice that this times 1, see this is 1. Anything divided by itself is 1, is this back. So 4t times b to the 4th then would give me 4 b to the 4th times t. I just put it in alphabetical order. You did not have to. So the answer, you're going to say 4t divided by a to the 5th, b to the 3rd, is equivalent to this. 4b to the 4th, t divided by a to the 5th, b to the 7th. Okay? All right, let's look at number 3. So number 3, let's suppose we had this. We have 7. Let's do this, I'm sorry. Negative 8 divided by 21, a to the 3rd, b squared. And then the other one is 4 divided by 15, a, b to the 5th. Okay? All right, so we got to find the least common denominator of those two rational expressions. So that's the first thing I want to do. It's given those two rational expressions, what's the least common denominator? So the notice that those are all monomial factors, so that's the easy kind. And so I can find the LCD of the variables first, and then let's just do the coefficients in a little while. So for the variables, I have 3 factors of a, 1 factor of a. So how many do I need? 3 factors of a. Then the other factor I see is a b. I have 2 factors of b here, 5 here. How many do I need? I need the largest possible, 5. Now let's talk about 21 and 15. What's the smallest number, I mean the least common denominator, the least common multiple? What's the smallest number that 21 and 15 go into? All right, so you may find this a little bit more difficult, but what you may want to do, remember in a lesson we looked at the prime factorization. So remember 21 is 3 times 7, so you can write every composite number as a product of prime numbers. And then 15 would be 3 times 5. And so notice the least common multiple of those two, you got to include every factor you see. I see a 3, I see a 5, and I see a 7. And the question is, how many of each do you need, though? So how many factors of 3 are in here? 1. How many factors of 3 are in 15? 1, so I just need 1. Let's go with the 5. How many factors of 5 are in 21? 0. How many factors of 5 are in 15? 1, so I need just 1. 7, remember, always use the largest amount, just like you did when we talked about these exponents here. For 7, there's 1 factor 7 here, 0 here, all I need is 1. So therefore, the LCD will be 3 times 5 times 7. So 3 times 5 times 7 is 105. And so your LCD is 105, a to the 3rd, b to the 5th. And now what you want to do is you want to write equivalent rational expressions for those two with this denominator. So then you're going to say negative 8 divided by 21, a to the 3rd, b to the 2nd power is equivalent. Oops, I forgot, I didn't do some space here. So let me go ahead and rewrite this. So negative 8 divided by 21, a cubed times b squared. You're going to have to multiply this by some expression to get an equivalent. You want an equivalent rational expression with this denominator. Okay, so let's see. So 21 times what's 105, so use your calculator if you need to. So 105 divided by 21 gives me 5. So you knew that had to be 5 because 3 times 7 is 21, and then 21 times this 5 gives you 105. So I need a 5. Now a cubed times what's a cubed? Well, that's 1, so I don't need any a's here. B to the 2nd power times what is b to the 5th? Well, b to the 3rd. But remember this right here is equivalent to 1 right here. So whatever the denominator is, I got to multiply the numerator by that same thing, by that same factor. And so therefore, negative 8 times 5b cubed is negative 40b cubed. And so there's your answer. So negative 8 divided by 21, a cubed b squared is equivalent to this, negative 40 b cubed divided by 105, a cubed b to the 5th. Okay, now the second one, this one here, let's see what we get. 4 divided by 15, a b to the 5th, times some rational expression, and I want to end up with this denominator. So 105, a cubed b to the 5th. So I want to write an equivalent rational expression of this to give me one that has this denominator. Okay, so what's missing? So 15 times 7, use your calculator, or you can say 15 times 7 is 105, so this needs to be a 7, is 105. A times a squared is a cubed. So notice this is a squared. B to the fifth times 1 is b to the fifth. So I don't need any b's here. But then I do need, whatever I multiply the denominator by, I got to do the same thing with the numerator because I've got to keep this equivalent. So that's why we talked about that 1. But 4 times 7a is 28a squared. So there's your answer. So 4 divided by 15, a to the times a times b to the fifth is equivalent to 28a squared divided by 105, a cubed, b to the fifth. All right? Okay, now all that's going to be important in the next lesson. All that. Okay, let's look at number 4. So number 4, we have, let's say this is number 4. So number 4, we have 7x divided by 3 times x minus 4. The other rational expression is 5x divided by 4 times x minus 4. All right. So look at those two rational expressions because that's what you're going to be doing in the next lesson. So the next lesson, you're going to be given two rational expressions and you're going to either add or subtract. So remember, when adding and subtracting rational expressions, the denominators have to be the same. Notice that these denominators are not the same. So that's why we're talking about finding the least common denominator. So the least common denominator must include every factor you see. And I want you to notice that these are already in factored form. These are listed as factors. 3, the other factor is x minus 4, the other factor is 4, and the other factor is x minus 4. So let's look at the coefficients first. What's the smallest number that 3 and 4 will divide into evenly? 12. Okay. Now my next factor C is an x minus 4. I have 1 here, 1 here. How many do I need? 1. And then that takes care of all of these. So you're done. So that's your LCD. Now the next thing you got to do is write equivalent rational expressions. So that's all going to take us into the next lesson. So 7x divided by 3 times x minus 4 times, I got to multiply that by some rational expression that's equal to 1. So that way I can get an equivalent rational expression with this denominator, 12 times x minus 4. All right, so look at what you have. So I already have that x minus 4 factor, right? So what some students will do is they'll kind of make a little note that they already have this. They want a 12, so that's a 3, so they know they got to multiply this by 4. But what I do, to remember, this has to be a 1. So what I multiply the denominator by, I have to do the same thing with the numerator. So 4 divided by 4 is 1. Okay? So remember that's how you wrote equivalent fractions. You wrote equivalent fractions by multiplying by some expression was equal to a 1 to get that back. So therefore 7x times 4 is 28x, and there's your answer. So 7x divided by 3 times x minus 4 is equivalent to this. 28x divided by 12 times x minus 4. Okay? Then the next one, this one, you have 5x divided by 4 times x minus 4. You want to multiply that by some expression to get an equivalent rational expression with this denominator, 12 times x minus 4. So again, I have the x minus 4, right? So what's missing? 4 times what's going to give me 12? Well, 3. So you multiply both numerator and denominator by 3 because that's the only way you can get that product to be a 1 right here, or that factor, excuse me, to be a 1. And so 5x times 3 then will be 15x. All right. And so what you found is that 5x divided by 4 times x minus 4 is equivalent to this rational expression. Okay? So those are your answers for this problem. So you found your LCD, that's one of them, and you found your two rational expressions that will be equivalent to each other. All right, now again, notice if you were to reduce, remember in one of the lessons a while back, you have to simplify rational expressions. So if I reduce this, I'll get this back by just dividing both numerator and denominator by 3. 15x divided by 3 is 5x. 12 times x minus 4 divided by 3, 12 divided by 3 is 4. You get that back. All right, so that's the whole idea. Okay, number 5, let's suppose we had this in number 5. We have x divided by x squared minus 25, comma, and then x minus 3 divided by x minus 5. So let's suppose we had that. So first thing you want to do is make sure that you factor your denominators. So you see that's x squared minus 25. That's the difference of two squares. So I can factor that as x minus 5 times x plus 5. And then x minus 5 I can't factor, so I'm going to leave that as it is. And so therefore let's find the LCD. So your LCD must include every factor you see in your denominator. So I see an x minus 5, I have to use it. Let's see how many we need though. I have one factor of x minus 5 here. I have one factor of x minus 5. I just need one. The next factor I see is x plus 5. I must have one. Question is, how many do I need? I have one here. I don't see any here, so I just need one. So there's your LCD. So that's your LCD. That's the answer for the LCD part. Then the next part you're going to do is you're going to write equivalent fractions for both of those with that denominator. So let's do this one first. So x, and I'm going to go ahead and use the factored form. X divided by x minus 5 times x plus 5. I know I got to multiply that by some rational expression to get an equivalent rational expression with this denominator. X minus 5 times x plus 5. Oops. Yep. Okay. So I want you to notice that this right here is this, isn't it? Y'all agree? So basically what you're doing is you're multiplying both numerator and denominator by 1 then. Because this x minus 5 times x plus 5 times 1 is this. And then so therefore x times 1 is just x. So what that tells us is this, what any of you understand is this, that every rational expression is equivalent to itself. That's what you found. All rational expressions are equivalent to itself because you can multiply every rational expression by 1, and you get the same thing in this case. So what I want you to find, what we found is this: x divided by x minus 5 times x plus 5 is equivalent. We want to use this denominator. So it's equivalent to itself. X minus 5 times x plus 5, with the numerator being x. So that's the answer for that part. Now for the next one, this one, you're going to have x minus 3 divided by x minus 5. You got to multiply that by some rational expression that's equal to 1. And you will end up with an equivalent rational expression that has this denominator, x minus 5 times x plus 5. Okay? All right, notice that I am missing something in this case because I have an x minus 5 only. So what I'm missing is this one. So I got to multiply. I have to multiply both numerator and denominator by x plus 5. And so the numerator then will be the product of these two binomials. So x minus 3 times x plus 5. All right, so your answer. And again, just like we talked about before, when we get to that point, at some process in adding and subtracting these in the next lesson, we may need to multiply the numerator out, but always leave the denominator factored. So basically what I want you to notice is that x minus 3 divided by x minus 5 is equivalent to this. X minus 3 times x plus 5 divided by x minus 5 times x plus 5. And we know that's true because if you simplify this, you're going to get this back because notice the x plus 5 is divided out and you're left with x minus 3 divided by x minus 5. Or you can write this as, if you FOIL the numerator out, you get x squared. That's going to be a positive 5x and a negative 3x is a positive 2x, and then negative 3 times 5 is 15. But always leave the denominator factored. Okay? So you can say r x minus 3 divided by x minus 5 equals that. All right. Let's look at number 6. So number 6, let's suppose we had, let's see real quick. Let's suppose we had this for number 6. We had, okay, number 6. We have 18 divided by p squared minus 81, comma, and then 7 plus p divided by p plus 9. Okay? So in this one, I have these two rational expressions. I got to first of all find the LCD. So let's factor this. This is the difference of two squares. So p minus 9 times p plus 9, right? So that's kind of like the one we just did. So I'm going to get the LCD to be p minus 9 times p plus 9. Because remember, you got to use every factor you see. All right, and then notice there's only one factor p minus 9, and then there's only one factor of p plus 9. All right, so I'm going to write equivalent fractions using that. So that's the same one we just did a while ago. P minus 9, p plus 9 is equivalent. And remember, you want to get a rational expression that's this. So it's just equivalent to itself. So that's just 18. So that's the first one was easy. That's just like the one we just did. And then over here, 7 plus p, I'm going to write this as p plus 7. So p plus 7 divided by p plus 9. I know that I'm going to have to multiply that by, so remember you want a denominator that's p minus 9 times p plus 7, right? So I already have the p plus 9. I need the p plus 7. So I got to multiply that by p plus 7, p plus 7. So basically what you have here is p plus 7 times p plus 7 is p plus 7 squared. So p plus 7 divided by p plus 9 is equivalent to p plus 7 squared divided by p minus 9 times p plus 7. Okay? And then if you want, you can follow the numerator out. Okay, number 7. Let's suppose we had this for number 7. We have x plus 2 divided by 2x squared plus 3x minus 9. And the other one is 3x divided by 3x squared plus 10x plus 3. All right, so notice I have to factor these denominators. So I got to find the LCD. So if I factor this, that's 2x and x. The last sign's negative, so those signs are different. And let's try 3 and 2. And let's put the, let's see. Let's put let's use 3s. So 3 and 3. And let's put this is negative, this is positive, and see if that works. So that's a 6x, that's a negative 3x, and I get positive 3x, so that works. Now let's over here, if I factor this, I'm going to get 3x, x, let's put the 3 here, the 1 there, and both positives, and make sure that works. So 9x and x is 10x. All right, that works. All right, so the LCD, remember the LCD must include every factor you see. I see a 2x minus 3. How many do I need though? I have 1 here. In this factor, I don't have any, so I just need 1. The next factor I see is x plus 3. So remember, your LCD has included every factor you see in every denominator. But you got to determine how many you need at some point. So I have 1 factor here. I have 1 here. I just need 1. Don't put 2 because that's no longer the LCD. That's a common denominator. Always use the least. The next factor I see is 3x plus 1. I have to use it. I have 1 here, none here, so I just need 1. And I already took care of the x plus 3 right here. So that's it. So your LCD this time has 3 factors. Okay? All right, let's talk about the equivalent fractions now. So let's do the first one. So x plus 2 divided by, and always use a factored form, 2x minus 3 times x plus 3. I've got to multiply this by some rational expression to get an equivalent rational expression. So I want this to be equivalent with this denominator. So 2x minus 3 times x plus 3 times 3x plus 1. Okay? And so if you look at what you have, so what do I need to multiply this denominator by to get this? So I have the 2x minus 3. I have the x plus 3, so I'm missing this one. So that's the one I'm missing. So I got to multiply numerator and denominator by that. Both numerator and denominator by both 3x plus 1 to get this rational expression, to get a rational expression with this denominator. So therefore the numerator will be this times this. So that should be a 1 here. So that would be x plus 2 times 3x plus 1. Okay, and if you want to follow this out, you can. So you can write this as if you follow the numerator. So at some point in the next lesson, we may need to multiply the numerator out. But you're going to notice the next lesson, we're always going to leave the denominator factored. So that's 3x squared. The outer and the inner is going to be 7x. And then 2 times 1 is 2. All right, so I found, what I found now is this. So I found that x plus 2. So answer, x plus 2 divided by 2x minus 3 times x plus 3 is equivalent to either one of these. So I'm just going to go ahead and leave it as, I'll do this one. Is equivalent to 3x squared plus 7x plus 2 divided by this denominator. 2x minus 3 times x plus 3 times 3x plus 1. Okay, now on the next one, you might say, oh, good Lord. Yeah, there's the next one right here. So all we did was we found an equivalent rational expression for that one, given this denominator. Now we got to do this one. Now you see in the next lesson, when we add and subtract, you're going to be doing all of this together. So that's why we're doing it in little steps. So we got to get to this before we can actually get to what we want to do next. So now for that one, we have 3x divided by, again, use your factored form, divided by 3x plus 1 times x plus 3. And I want to multiply this by some rational expression, so that way this is going to be equivalent to a rational expression with this denominator. 2x minus 3 times x plus 3 times 3x plus 1. So if you look at what you have, so what do I need to multiply this by to get this? So I have the 3x plus 1, I have the x plus 3, so I'm missing this one, right? So I got to multiply. So what goes here is going to be the 2x minus 3. So 2x minus 3. But when I multiply by the denominator, I got to do the same thing with the numerator, because remember, this fraction has to be a 1. So therefore, we get 3x, a monomial times this binomial. So I get 3x rather, times 2x minus 3. So there's your answer. Okay? And remember, those are equivalent, because if you reduce, see how the 2x minus 3's divide out? You get 3x divided by this product, which is this. All right, so here's the idea that 1 right here. Okay, and so your answer, then you could say 3x divided by this product is equivalent to this rational expression with this denominator. And then if you want to, you can leave it in factored form, or you can distribute. So you can write the numerator as 3x times 2x is 6x squared, and then 3x times a negative 3 is negative 9x. Okay? But always leave the denominator in factored form. You're going to see that in the next lesson. All right, so that was number 7. Let's look at number 8. So let's suppose in number 8, I had this, number 8. Okay, so number 8. So let's see, number 8. Let's do another one like we just did, just to give you a little bit more practice with this idea. So let's look at number 8 and make it this one. So it'll be t plus 4 divided by t squared minus t minus 30. So there's your first one. Your second rational expression is t minus 8 divided by t squared plus 2t minus 15. All right, so let's talk about this one again. So it's very similar to what we just did. So we got to factor the denominators. So you're going to see that in the next lesson as well. So when we factor the denominators, I'm going to get t minus 6 times t plus 5. That will give me that. Over here, that's going to be t plus 5 times t minus 3. Okay? And so now I've got to find the least common denominator of all of those two denominators, those two fractions. And so your least common denominator will be every factor you see. Okay? Every factor you see. So you're trying to find the least common multiple of those two denominators. So I get I see a t minus 6, I got to use it. Question is, how many do I need, though? So notice there's only one factor here, 0 here. You just need that one. Next one is x plus 5 that I see. I have one here, I just need 1. Only put a 1. Don't put more than 1 because that's no longer a common denominator. That's no longer the least. It's a common denominator. So the next factor I see is x plus 5. I already have. The next factor I see is t minus 3. That should be a t here. T minus 3, so I need that one. And so there's only one factor, 0 here, so I just need that one. So there's your LCD. So your LCD, again, just like in the previous one, has 3 factors. So now I'm going to write equivalent fractions now. So let's do with the first one. So t plus 4 divided by, and always use a factored form. That's important. T minus 6 times t plus 5. So I want to know, what is it I got to multiply this by so that way I can get an equivalent rational expression that has these 3 factors as my denominator. That's the question. All right, so you know that if you look at this, so I already have the t minus 6, and I already have the t plus 5, so I'm missing the t minus 3. So I'm going to, that's a 3 right here. So I'm going to multiply both numerator and denominator by t minus 3. Okay, t minus 3. Because remember, t minus 3 divided by itself is 1. So whatever you multiply this by, that fraction will reduce, still better be a 1. And so now what we have is that this times this times this is this, and then the numerator is just these 2 binomials multiplied together. So t plus 4 times t minus 3. And then you're done. So the answer, at least for the first one, so now your answer is going to be this. So you're going to say t plus 4 divided by t minus 6 times t plus 5 is equivalent to this rational expression. T plus 4 times t minus 3, and leave the denominators factored, t minus 6, t plus 5 times t minus 3. And you know that's true right here. And you know that's true because if you reduce, see how the t minus 3's divide out? So if I kind of cover it up, what you have is this. See that? So those are equivalent. See, what I have covered up is 1. That's this part here. Now, if you want to multiply the numerators out, that we may need to do that in the next lesson. So it's always know how to multiply binomials. So using a FOIL method, so I get t squared. The outer and the inner is going to be just t, and 4 times negative 3 is negative 12. But always leave the denominators factored. Okay. Now the next one right here, same thing. So we're gonna write. So that takes care of so the answer for the LCD is this. So that's one of your answers. The answer for the equivalent fraction for this one is this. So that's the other one. And then let's work with this one now. So t minus 8 divided by, again, factored form, t plus 5 times t minus 3. You can multiply that by some rational expression. That's going to be a 1 right here. And you want to end up with a rational expression that's to an equivalent rational expression that has this denominator. So t minus 6, t plus 5 times t minus 3. And so if you look at what you have, I have the t plus 5, I have the t minus 3, so I'm missing the t minus 6. So that means I got to multiply both numerator and denominator by t minus 6. And so now what I have is that the numerator then will be the product of these two. So t minus 8 times t minus 6. And so therefore your answer then, you're going to say the t minus 8 divided by t plus 5 times t minus 3 is equivalent to this. T minus 8 times t minus 6 divided by this product. T minus 6, t plus 5 times t minus 3. And again, you know this is correct, because if you cover up, see how the t minus 6 is, you can reduce. So if you cover that up, what you have left is this right here. See the t minus 8 in the numerator, and you see this part here is this. Okay. Now, if you want to distribute, if you want to multiply the numerators out using a FOIL method, you can. So t times t is t squared. The outer is a negative 6t. The inner is a negative 8t. So I get negative 14t. And the negative 8 times a negative 6 is a positive 48. All divided by this. Again, always leave your denominators factor. You're going to see in the next lesson that when we add and subtract, we're going to leave the denominators in factored form. We may at times have to multiply the numerators out to get what we need, and we'll talk about that in the next lesson. So that takes care of number 8. So that's number 8. And let's do one more, just to give you another example. Let's do one more. Let's look at this one. So this will be number 9. Okay, so number 9, real quick, and that'll be the last one. So I think you should have enough problems to be able to understand the next lesson. So number 9, let's suppose we have t plus 3 divided by t squared minus 16. That's my first one. And my second one's t plus 7 divided by t squared minus 7t plus 12. So again, the first thing you got to do, since I have a polynomial that's not a monomial, is factor these denominators. So here, that's going to be t plus 4, t minus 4. That's the difference of two squares. Here, let's see what we get. That's going to be t negative, subtraction, because the last sign is positive. So these signs have to be the same. And I think we need a 4 and a 3. Okay. So therefore, my LCD, you also know now how to find the LCD. I need a t plus 4, and I just need one of them because there's one here, none here, 0 here. Next one I see is a t minus 4. I just need one because there's one here, just need one. I already have the t minus 4. The next one's a t minus 3. So I got to use it, and just need one. So there's your LCD. So now you're going to write equivalent fractions. Let's start with the first one. So t plus 3 divided by, and use a factored form, t plus 4 times t minus 4 is equivalent. So I got to multiply that by some rational expression to get an equivalent rational expression with this denominator. So t plus 4, t minus 4, t minus 3. So based on all that we've talked about, what do you think you got to multiply both numerator and denominator by? What do you think? Okay, good. So you know you have the t plus 4 already. The t minus 4 is here, so you got to multiply by t minus 3. So t minus 3, t minus 3. And so therefore my numerator then is going to be the product of these two. So t plus 3, t minus 3. Okay? Or if you want to, you can multiply the numerator out. That's going to be, if you follow it, that's going to be t squared minus 9. But never, you're going to see that do not multiply the denominators out. Leave it alone. In fact, I would not want to multiply this out. Okay, so your answer for that one is going to be t plus 3 divided by t plus 4 times t minus 4 is equivalent to either one of these. Does not matter. T plus 3, t minus 3 divided by t plus 4, t minus 4 times t minus 3. Or you can say this. Okay? All right, so that's that first rational expression. Let's do the next one. So that takes care of the first one. So the next one, meaning this one, so here I have t plus 7 divided by t minus 4 times t minus 3. So I got to multiply that by some rational expression that's equal to 1, because this times whatever this is, which is a 1, will be this back. Okay? And you want to find out what rational expression is equivalent to this that has this denominator. T plus 4, t minus 4, t minus 3. All right, and so notice that in this one I have the t minus 4, I have the t minus 3, so I need to multiply by that. So t plus 4, t plus 4. Okay, so notice that this product is this now. So all you got to do is, the numerator is going to be this then, the product of these two. So t plus 7 times t plus 4. So what you found for your answer is this. And it knows, well, let me go ahead and write it out. So your answer is going to be t plus 7 divided by t minus 4 times t minus 3 is equivalent to this. t plus 7, t plus 4, divided by t plus 4, t minus 4, t minus 3. Okay, those are equivalent. You can actually see that because look, if you simplify this rational expression, the t plus 4's divide out. See, those divide out, right? So if you kind of cover it up like this, notice what you see. You see a t plus 7, and you see this product, which is this. All right, so that's the answer. So that's what you found. And notice notice that when you divide the t plus 4's, that's this right here, isn't it? That's that 1. Okay? All right, so that's the end of that, and you could multiply this out if you want to. But don't multiply the denominators out. Leave the denominator in factored form. Okay, so that's going to be the end of this lesson. So I think you should have enough problems. So we had enough discussion to get you to understand how to write equivalent rational expressions from this lesson and also from the previous one. So that should help you. That should help you in the next lesson where we have to add and subtract rational expressions with unlike denominators. Okay, so that's going to be the end of this lesson.